Let's talk about solving systems of equations by substitution. So we've seen how to graph systems of equations. That's just when you've got like two lines, say like y equals 3x plus 5 and y equals negative x plus 10, and you just graph both of the lines and you see where they meet. So 3x plus 5, let's say this is 5 and this is 10. So 3x plus 5 probably going to look something like this. Then negative x plus 10 going to look something like that. And then the solution is that point there where they cross. But well, I haven't drawn the best graph here. I'm sorry. But this kind of illustrates my point that if you want to solve it graphically, you have to take a lot of time to draw a really good graph. And sometimes even if you draw a really good graph, you could still be wrong. I don't know. It's easy to slip up that way. So let's talk about how to solve them by substitution, how to solve them algebraically. So substitution is just substituting what one variable is in another variable. Sorry, that probably didn't make a lot of sense. But you see this y here in the first equation? Well, we've also got a y in the second equation. So why don't we substitute the expression for this y in for the y in the first equation? So we're going to take what we know for y. We know that the y's are equal. So we want to put in the x values for them. So we can say that negative x plus 10 equals 3x plus 5. And now we can just solve the equation. So add x to both sides, get 10 equals 4x plus 5, and then minus 5 over there. So 5 equals 4x, and then divide by 4, 5 fourths equals x, or x equals 1.125. Not 125, but just 1.25. And then we can find the y just by plugging it into either equation. If we plug it into the top one, we get y equals 3 times 1.25 plus 5. Well, that's equal to 3.75 plus 5, which is 8.75. If we plug it into the bottom one, we get y equals negative 1.25 plus 10, which, guess what, that's also 8.75. Cool. So our solution is 1.25 comma 8.75. That works for both of them. So this was, that's the method of substitution. You just set one variable. You just eliminate one of the variables this way by substituting in for it. Now it doesn't always have to be like y that you sub in for. You don't have to always solve it for x. Like what if let me draw up a new set of equations. What if we have something like, say we have something like x plus 20y equals 2, and then x minus 18y equals 5. Well, if we're going to solve for y in both of these, then that's just going to lead to a bunch of nasty fractions. But why don't we just solve for x here? So x equals 18, y plus 5, and then we'll combine both of these equations. We'll put the x into this x over here, and then 18y plus 5 plus 20y equals 2, 38y plus 5 equals 2, 38y equals negative 3, y equals negative 3 over 38. That wasn't too bad. We only had to divide at the very end. Otherwise, no fractions whatsoever. But if we solved for y here, we'd just be a mess of fractions. I'm not going to do that. You can do that if you want to, but I really don't want to. Let's do one more substitution problem. Something where they're not equal to be. So let's take 3x plus 4y equals 18, and 2x plus 2y equals 3. So I think that what's probably easiest to do here is to solve for y in this equation, just because we'll get just fractions of like out of a half, and then since there's a 4 in front, that'll turn them back into whole numbers. So let's solve for y there. So we get 2y equals 3 minus 2x, y equals 3 halves minus x. And then we'll plug it back into this first equation, and then we get 3x plus 4 times 3 halves minus x equals 18. So 3x plus 4 times 3 halves, that's just like 12 over 2, which is 6. You can also think of that as 4 divided by 2 is 2, then times 3 is 6, or just 4 times 1.5 is 6, however you want. Minus 4x equals 18, and then 6 minus x equals 18, minus x equals 12, x equals negative 12. Great. We'll just solve for y also. So if we plug that back into this equation, it doesn't matter which equation you pick, but I'm just choosing the one with smaller numbers. So 2 times negative 12 plus 2y equals 3. Actually, I'm being silly right now, because we already have y right here. So we can just sub it back into there. So y equals 3 halves minus negative 12 equals, I'm just going to write this 1.5 plus 12 equals 13.5. And yeah, we can check this. It's always good to check your answers afterward, just to save yourself and your teacher or tutor some headache of going through all your work. And so we've got 3 times negative 12 plus 4 times 13.5. That's negative 36 plus 4 times 10 is 40, and 4 times 3.5 is, 4 times 3 is 12, and 4 times 0.5 is 2. So negative, I'll just combine these. So that's 4 plus 12 plus 2, that's 14, 18. Hey, that matches up with 18 here, good. And then 2x, 2 times negative 12, 2 times negative 12 plus 2 times 13.5 is negative 24 plus 27. That's 3. Okay, cool, that matches up also. So then we know we did it right. So that's our final answer. You can write it as an ordered pair, negative 12, 13.5.